So number 1 says, let's find the definite integral from -1 to 1 of 3x squared times the square root of the quantity of x cubed plus 5 dx. Oh my gosh, that is not a d. dx. Alright. So let's just go into our u substitution. So you let u equals x cubed. Sorry, this should be plus x cubed plus 5. So then du is just 3x squared dx. And then we just substitute that and make the substitution. So then we have u to the 1/2 du. And this should be simple enough. So we just take the derivative, or the antiderivative rather, and we get equal to evaluated from -1 to 1. And this is really just equal to, so we could substitute x cubed plus 5 back in for u. Plus 5 to the 3/2 evaluated from -1 to 1. Alright. So this is what we have so far. And then we just evaluate the integral. Take this over here. So this is 2/3 times 1 cubed plus 5 to the 3/2 minus, and let me move this a little, minus 2/3 times -1 cubed plus 5, oh my goodness, to the 3/2. So to simplify, we get, actually we can factor out a 2/3, so we get 2/3 times, and this is just 6, so 6 to 3/2, that's just square root of 6 cubed, minus, this is just 4, so minus square roots of 4 cubed, and this we know is just 64, so that's just equal to 2/3 times 6 square root 6 minus 8, right, because square root of 64 is 8. So then we end up with, these cancel out to become 1 and 2, so you get 4 square root 6 minus 16 over 3. That is our answer. Alright, so number 2 says find the antiderivative of x cubed times the quantity of 2 plus x to the 4th all to the 5th dx. So we start with our u substitution. U equals 2 plus x to the 4th. So du equals 4x cubed dx. So from here we get 1/4 times the antiderivative of u to the 5 du, which is equal to 1/4, and then if we take the antiderivative we get u to the 6th over 6th plus c, can't forget that plus c, which eventually simplifies out when we substitute back in 2 plus x to the 4th for u. We get 2 plus x to the 4th quantity to the 6th over 24 plus c, and that is our answer. Okay, so we're trying to find the definite integral from 0 to 7 of square root of 4 plus 3x dx. So we can let u equal 4 plus 3x. So du is just 3 dx. Okay, so from here we can rewrite this as 1/3 times, oh my god, times the definite integral from 0 to 7 of u to the 1/2 du du, which can then be simplified to 1/3 times, and this would just become 2/3 u to the 3/2 evaluated from 0 to 7. So we take this up here, we substitute 4 plus 3x back in for u, and we can factor out a 1/9, or actually in fact a 2/9. Hold on. We can factor out a 2/9 because we have 1/3 and 2/3 here, times 4 plus 3x to the 3/2 evaluated from 0 to 7, which is just equal to 2/9 times, so 7 times 3, that's 21, plus 4, that's 25, so the square root of 25 cubed minus the square root of 4 cubed. This is just it's 15625, and then this is just 64. So this is just 2/9 times square root of this is 125 minus 8. 125 minus 8, that's 117. 117 times divided by 9 cancels out to be 13. So all this eventually comes out being 26. Okay, so we're trying to find the antiderivative of 1 over the quantity of 1 minus 6t to the 4th dt. So we can let u equal 1 minus 6t. Oh my god. So we have du is equal to negative 6 dt. So from here we just have negative 1 over 6 times the antiderivative of 1 over u to the 4 du, which is equal to negative 1 over 6 times the antiderivative of u to the negative 4. So if we bring this up here, we get this as negative 1 over 6 times u to the negative 3, or rather negative u to the negative 3 over 3 plus c. Can't forget that plus c, which is equal to, if we multiply this out, we just get 1 over 18 times u to the negative 3 plus c. And then if we substitute back in 1 minus 6t for u, we just get 1 over 18 times 1 minus 6t cubed plus c. And this is our antiderivative. Okay, we're on our last problem here. It says find the definite integral from 0 to square root of pi of x times cosine of x squared dx. So we can let our u be x squared, meaning that our du will be 2x dx. 2x dx. So if we come from here, this is equal to 1/2 times the definite integral from 0 to square root of pi of cosine of u du, which is equal to 1/2 times negative sine u, using our trig properties, negative sine u evaluated from 0 to pi. Or sorry, not 0 to pi, 0 to square root of pi. My apologies. So we come back here, if we substitute back x squared for u, we would get 1/2 times negative sine x squared evaluated from 0 to square root of pi. And now we can plug in these two values, so this eventually becomes negative sine of pi over 2 minus negative sine 0 over 2. We know that sine of pi is 0, so negative 0 over 2 is just 0. And we also know that sine of 0 is 0. So negative sine of 0 over 2 is just 0. So this is 0 plus 0, which just turned out to be 0. And that is the answer to this problem.